Hello everyone, welcome back to this online class. Today I want us to look at one application of finite difference tables, and in particular we are going to look at the detection and correction of errors in any given table of data. So we are given this question. We are asked to discuss the detection and correction of errors in a table of data, hence detect and correct the mistake in the following data. So we have that table of x and f of x. Now, once you detect and correct the errors, you then need to extend the corrected table to predict f of -5 and f of +5. So first of all, let's talk about error detection and correction. So as you know that FD tables, the finite difference tables, can always be used to detect errors in any given table of data with uniformly spaced tabular points. So the requirement is that the x values must be uniformly spaced. So take note, NB, x values must be uniformly spaced. If that is not the case, then you cannot use finite difference tables to detect the error in that kind of a table where the x values are not uniformly spaced. So the requirement is that the x or the spacing must be uniform. The interval of differencing must be uniform. So I want us to consider this table. Consider the table below. We consider the following table with an error E, table below with an error. Let's say the table has an error of, you can call it epsilon, a very small error in one of the tabular values. In one of the tabular values. One of the tabular values, let's say f of x, let's say f of x, x3. Or simply f of x4 as an error. So those tabular values without the error, we are going, because we are tabulating the x values against the error. So we have this table, or let me use another color. We have x and f of x. So let's say we have x0, x1, x2, x3, x4, x5, x6. So we can go all the way up to, let's say we can go up to x10 for this particular table. X10 will be too long. Let's go up to x8. So x6, x7, then x8. And the f of x values, this will be f0. Remember, when we talk of f of x4, this is simply f4, which has an error. So f1, f2, f3, f4, f5, f6, f7, F8. So I need to know the error in each of those functional values. So I'll add here another row for the error. Let's say error term. It's not even a function of x, but a constant. So you can just have e to denote the error. So error e. So remember that only F4 has an error in it. The other functional values are correct. They don't have any error. And you know how to get an error. The error is always the actual value minus the approximate value. So let's say, of course, there's no error. So the error is 0 here. In F1, there's no error. In F2, no error. All the way. Here we said the error is epsilon. This one does not have any error all the way up to F8, except F4, which has an error of epsilon. So what I'm going to do, I'm going to construct a finite difference table, the x values and the values of the error. So you see, this is the data table, or the table of data. You went to the field, you collected some data, maybe while recording, you realize that you didn't even realize, but in the process of analyzing the data, you realize that you have an error, and you want to know where did that error arise from. So in this case, we are assuming let F4 be the value that was recorded wrongly with an error of epsilon. So come up with a finite difference table. We want to see how the error spreads. So you can write here finite difference table for the error. Let's see how the table will look like in this case. So I'll have, here we'll have x and the error. Then the horizontal line, the vertical line. That should be a vertical line. So we have x1, x0 all the way up to x8. So I'll list them down here. Let me extend this vertical line. Extend it because my data points, so the tabular values are so many. So we'll have here x0. The error corresponding to x0 is 0, x1, 0, x2, 0, x3, 0, x4, the error was epsilon, x5, 0, x6, 0. We still have two more. x7, 0, and x8, 0. So I'll extend this. So, as usual, let's come up with the differences, the higher order differences. For the first order difference. 0 minus 0 is 0. Again, 0 minus 0 here is 0. Here again, 0 minus 0. Epsilon minus 0, that's epsilon. 0 minus epsilon is negative epsilon. Here we have 0. Extend it. Here 0 minus 0 is 0. Again, here we have 0. That's the first order differences. Let's see the second order differences. Again, subtract 0. Let me use another color. 0 minus 0 is 0. Again, this is 0. Epsilon minus 0 is epsilon. Negative epsilon minus epsilon, that's negative 2 epsilon. 0 minus negative epsilon, that is a positive epsilon. 0 minus 0 is 0. Do we have another one? Yes. Another 0 minus 0 here is 0. We go to the third order differences. I can use another color. 0 minus 0 will give us 0. Epsilon minus 0 is epsilon. Negative 2 epsilon minus epsilon is negative 3 epsilon. Epsilon minus negative 2 epsilon, that is positive 3 epsilon. Here we'll have negative epsilon. And the other one, here we'll have 0. We don't have any other. Let's see what we'll get in the fourth order differences. Fourth order. So epsilon minus 0, that will give us epsilon. Negative 3 epsilon minus epsilon, that is negative 4 epsilon. Here we'll get 6 epsilon, a positive. Here we will get, is it negative epsilon minus, that's negative 4 epsilon. And here we'll get epsilon. We could go all the way up to the fifth order, 6 etc. But I want us to see how the error spreads. Look at, let us track it from, because x4, instead of recording the correct value of f of x4, we recorded the wrong value, and so there was an error of epsilon. Let's see how that error is propagated, how it spreads. So we track it from here. See how it is propagated. Another one is this other side. Let me draw it in a better manner. So the error spreads in this manner. And you see, as if you continue with the higher order differences, the error becomes even bigger as the order increases. So what are the observations that we make from this particular table? I want us to list them down here. There are various observations that we can see, we can take note of from this table. So our observations. I'm going to write them down. The first observation is that the error spreads and increases in magnitude. The error spreads and increases in magnitude as the order of the differences is increased. And you can see it. If I were to include fifth order, sixth order, you'll see that this thing, because these lines, they are like diverging. So it means even the error it will spread more as we go to higher and higher order differences. Another observation that you can make from this analysis is that the algebraic sum of the errors in any difference column is 0. Of the errors in any difference column is 0. What I mean is this. Look at the first column. You see this one was negative. So if I add the error, the total of each column, this positive epsilon, negative epsilon, when you add them, that is 0. What about the second order column? Epsilon minus 2 epsilon plus another epsilon, that is 0. What about the third column? If I take this plus this plus this plus this, I get 0. Let me get rid of those ticks. Again, fourth column, if I take this plus this plus this plus this plus this other one, I'm going to get 0. So that explains the second observation. Another observation, you write number 3. Another observation from that table is that the coefficients of the error, the coefficients of the error, our error is epsilon, coefficients of the error in any difference column, in any difference column are the same as the binomial coefficients, are the same as the binomial coefficients in the expansion of one minus x raised to n, where n is the order of the difference. N denotes order of the difference. Let me explain this. Look at, okay, you know, if we have 1 minus x raised to 1 is equals to 1 minus 1x. So the coefficients in that expansion is 1 and negative 1. Look at the first column. Here we have 1 epsilon, and here we have negative 1 epsilon. So you see those coefficients, they are the same as that expansion, the coefficient in that expansion. Let's look at now when we are in the second column. So our n will be 2. When we talk of second order, look at 1 minus x raised to 2. That is 1 squared minus 2x plus 1x squared. So that the coefficients are 1, negative 2, and 1. They are here. Here we have 1. Here we have negative 2. And here we have 1. What about, I can also talk about the third order. When we expand, when n is 3, 1 minus x raised to 3 is the same as 1 cubed minus 3 times 1 squared times x plus 3 times 1 times x squared, then minus x cubed. The coefficients are 1, negative 3, 3, negative 1. You see it here? 1, negative 3, 3, negative 1. So they are there. And so that even if you expand when n is 4, you'll get the coefficients to be 1, negative 4, 6, negative 4, 1. So that explains the third observation. And another observation, the fourth one, so right here in Roman 4, that the error is maximum. The error is maximum Of course, in magnitude, along the horizontal line, horizontal line, through the tabulated value containing the error, through the tabulated value containing the error. This is what I mean. Look at the value at the one that had an error was f of 4. This was f when x is 4. I mean f of x4, or simply f4. So when I draw a horizontal line from f of x4, it will be such kind of a line. If you look at any column, look at the fourth column, and look at those errors. The maximum is 6 epsilon. When you get the magnitude, I mean in absolute. Magnitude means absolute value. So 6 epsilon is more than 4 epsilon, more than epsilon. Again here, you see here we have negative 2 epsilon. Absolute of that is 2 epsilon. 2 epsilon is more than epsilon and the other epsilon. If you look at any particular differencing, or simply any particular order, any particular column, you realize that the maximum value will be along the middle line. Maximum value of that error will be along the middle line, that horizontal line. So therefore, what you can say is that large fluctuations in the differences indicate possible errors in the tabular values. Tabular values are the x values. And of course, small fluctuations may be as a result of rounding off. Of course, you see, when you round off, there's an error. There's what you call the round off error. So there will be a fluctuation, but those are just as a result of round off. Now, there's something we need to take note of. The first note is that in any difference column, the differences do not follow a smooth pattern. If in any difference column, the differences do not follow a smooth pattern, then the error exists in one of the tabulated values. Another note that you need to take note of is that if the differences in any difference column, especially the higher order differences, alternate in sign, then the middle entry contains an error. It must contain an error. And another note is that, you see, once you know this error, you'll always want to correct it. How do you get to the original figure that you're supposed to record? So you need to take note. This is very important, so let me write it down. That if f star is the tabulated value, the tabulated function of value with an error, the error is epsilon, then the correct function of value f is given by, then the correct functional value f is given by, so if you want to get the correct value, it is f is equals to f star minus the error. That's how to correct that error using this formula. This is how to correct the error. How to correct the error. So F star is the one that you recorded wrongly. If you now know the magnitude of the error that you encountered, then take what you recorded wrongly, subtract the error that you encountered. And you know error can be negative or positive. If you get a negative, it will be minus negative of that value, so that you get to the correct value that you ought to have recorded in your table. So, having discussed those ones, let's now answer the question. Look at our question, because already we have discussed everything that entails error detection and correction. Now, let's go back to our question. We are asked to detect and correct the mistake in the data given below. This is the table. So let us draw it and then see how to detect the error and also how to correct the error. So I'm going to draw the table. So we need to answer the question or work out the question. So that table, come up with the finite difference table. What we do is to construct a finite difference table. A finite difference. That should be difference, finite difference. I'll be abbreviating this as FD, construct finite difference table for the data. So we need the X values, and we also need the F of X values. Horizontal line, then the vertical line. So let me extend this line. So I need to populate this table. You know the X values, that is X was from -4 to +4. And then you also write the corresponding F of X values. So fill that table with the values that we have up there. So this is the table. We have filled the table with the X values and the values of F of X. I don't know where the error is, but we are going to use this finite difference table to be able to detect the error. So let's get the differences. So we start with the first order differences. We're going to write them here. So -65 minus -3, that's the same as -65 plus 3, that's -62. Do the same, -49 minus -65, that should give us 16. So do the same subtraction, -15 minus -49, that should give us +34. So proceed in the same manner to get the remaining values under the first order difference column. So that's what we have as the differences under the first order difference column. Do the same to the second order differences. A similar subtraction, 16 minus -62. That should give us 78. 34 minus 16, that should give us 18. So proceed with the same subtraction until you get to 74 minus -24. That is under the second order column. So those are the correct values under the second order difference column. Let's go to the third order. Remember, we're proceeding until you get to a constant figures under a particular column, so that it means when you subtract the same constant minus the same constant, you get 0. So there's no need of writing the zeros. We go until we reach to a constant figure. So 18 minus 78, that's negative 60. That's negative 60. Let me write that 0 in a proper manner. Negative 18 minus 18, that's negative 36. Proceed with the same subtraction up to 98 minus 8, which is positive 90. So you proceed in the same manner. So these are the correct values under the third order column. Let's go to the fourth order column. Fourth order. Do the same subtraction. Let's see. Negative 60, no, negative 36 minus negative 60. That should be able to give us 24. Negative 12 minus negative 36, again, that is 24. 12 minus negative 12 is 24. You see, this is constant, 24 throughout. 26 minus 12, that is 14. Now it means the error is here. There's an error here. 90 minus 26, that should give us 64. And you see, once there's an error, it will propagate. Even the other values will have an error. So let's see where the deviation starts. I'm going to draw a line just to show you where that kind of a deviation. You see, it is 24 throughout. This okay. It means the values under the fourth order column, if suppose you had written that value correctly in your data or simply table of data, then it means the values under the fourth order difference column should be 24 throughout. So when you see 14 and 64, it means there's an error automatically. So where did that error come from? Let's track 14. Let's track 14. This 14 will land us to this value here. If we track it, look at how the error was propagating in our table. There's a line that is sloping upward and another line sloping downward from the value that was wrongly recorded in your table of data. So where the error starts is where we have 14. So I'm going to draw this. Here is where our error is, and even this other side will have an error. This other side. So this is how the error is propagated in this manner. So all the values between those two lines, those ones are not correct. Even the values along those lines, those ones are not correct. So there's an error. So let's see our table here for the error detection. You see the error starts from epsilon. That's where we have negative. That's where we have 14. Then it propagates. Now you see the next one is negative 4 epsilon, followed by 6 epsilon, followed by negative 4 epsilon, followed by epsilon. That is when you are in the fourth order column. You can see it was in the fourth order column. So we are comparing the same columns. So I'm going to compare the fourth order column. And you see, I expect instead of 14 here, there's an error. So the error there is, if I take 14 plus the error, I should be able to get 24. I don't know the error, but 14 plus the error should be able to give us 24. So what is the error? Or simply this is what you do. This is what we do. That 14, the value that is recorded here, the wrong value should be equal to the correct value, which is 24. plus the error. You remember we said, let me write a note here. We said the corrected value, or simply f star, the wrong value, should be equal to the correct value plus the error. That's the formula I'm using. You can see it from here. If you make f star the subject, it is f plus epsilon. But now because the error has propagated, in the next one, we are not going to say, let me take you here so that I can be able to explain this other one. Instead of 64, it should also be 24. Do we write plus the error? No, it is plus -4 epsilon. Somebody might be wondering, why am I introducing -4? Look at here. Look at the fourth column here. You see, we were starting with epsilon. The next was -4 epsilon because the error is growing. It is not a constant, it's growing, it is propagating. That's why it is -4 epsilon. So even if you had another value, it will be plus 6 epsilon, 24 plus 6 epsilon going onwards. But I can see from here, we don't have any other value, so we stop there. So when you solve these equations, what do we get here? Here we are going to get epsilon is equals to -10 when you solve it. Even here, you're going to get epsilon is equals to the same, -10. Because you have 64 minus 24, that is 40, divided by -4, that's -10. So our error, the magnitude, or simply the error that is involved in that given table is -10. And where does it come from? It comes from the value that was recorded as -69. It means this was a wrong value. So what do you think is the correct value? This is the f star that I'm talking about, the wrong value. So to get the correct value, f is equals to f star minus the error. And so the wrong value that was corrected was -69 minus the error, which is -10. And so this should give us -59. So the correct value that you ought to have recorded in your table should be -59 instead of -69. So we have we have detected the error and we have corrected it. So instead of -69, the correct value should be -59. So with that correct value, come up with another finite difference table, because now we want now to be able to use the corrected table to predict the value of f of 5 when x is 5. What is the value here? F of 5, I don't know that. I also need to predict the value when x is -5. What will be f of -5? But now using the corrected table. So you can say use the corrected table to predict f of 5. Let me start with f of -5, f of -5, and f of 5. So I'm going to say let f of -5 be a. Let this value be a. Let it be equal to a. And let this other one be equal to b. So I want to construct the correct table. Now with the corrected value, instead of -69, it should be -59. So let's construct the correct table. We'll have x, f of x, x, f of x. So this other line. Remember now we are starting with the a, which we need to predict. The value here is -5. The value here is a. -4. What was the value when x was -4? That was -3. So fill the remaining values until you go to x is equals to +5. So this is our table. Remember, I have replaced -69 by -59 because that was the correct one. I need to find the values of a and b. So a is this one, that is f of -5, and b is this f of 5. So we are going to construct to obtain the higher order differences all the way up to the fourth order differences. So let's start with the first order. The first order. Subtract -3 minus a, that's -3 minus a. Here, -65 minus -3, that should give us -62. So proceed with the same subtraction. That is under the first order column. So these are the values under the first order difference column. Let's also populate the second order difference column. So -62 minus 3, of course, minus a, so it's a minus of everything. Minus and a minus is a plus. That would be -62 plus 3 plus a. And so that should be able to give us -62 plus 3 is -59, then plus a. 16 minus -62, that should give us 78. So you can proceed with the same subtraction. So these are the correct values under the second order difference column. Let's see how to get the values under the third order difference column. So again, you subtract. Here we'll have 78 minus -59 plus 8. So that's 78 plus 59 minus a. So you can press that in your calculator. And of course, what you need to press is the 78 plus 59. That is 137. So I'll write it here. 137. Remember, it is minus a because we are subtracting. 18 minus 78, that should give you -60. Proceed with the subtraction under the third order column. So these are the correct values under the third order column. Let's see the values under the fourth order column. Fourth order difference column. Again, we subtract -60 minus 137, then plus a, because a minus and a minus is a plus. So I'll simply press -60 minus 137. That should give you -197. I'll write it here, 197. And then it should be plus a. So 197 plus a, -197 plus a. What about -36 minus 60? So what are we going to get? Minus -60, I mean. That should give us +24. Similarly, negative 12 minus negative 36, that is 24. 12 minus negative 12 is 24. 36 minus 12 is 24. Proceed 60 minus 36, that again is 24. And finally, b minus 147 minus 60. What is 147 minus 60? So that should give us negative 207. So it's b minus 207. So you see in the fourth order column, everything should be equal to 24. So the value here should be equal to 24. And even the value here should be equal to 24. So when you solve these equations, you need to get the, here will give you the value of A. This other one will give you the value of B. So from here, what do we get as our A? Our A is equals to, you can solve it, make A the subject, 197 plus 24. That should give you 221. Here you'll get the value of B. That is 207 plus 24, that is 231. So now we know the value of f when x is negative 5. So you can just say therefore f of negative 5, let me just write here, therefore f of negative 5 is equals to 221, and f of 5 is equals to 231. So you see the way that is very simple. So we have seen how to detect the error in any given table of data and also to correct that particular error. And going ahead to predict the values of f of x given the x values, just like we have done in this example. So thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at more problems involving application of finite difference tables. Bye-bye.